So I will change.
Good morning, ladies and gentlemen. It's my great pleasure to introduce our first speaker today, Dr. Carsten Miller, who will talk about the use of software sketchometry in the teaching and learning of mathematics. Besides developing of this software, Carsten Miller is also prominent teacher educator in Bavaria, involved in a lot of projects, national and international, several of them with our university. He has very close relation to the Czechia, because among his hobbies is also study of Czech language. So you can speak with him in Czech, but slowly.
Ale nevím, jestli rozumím. Děkuji. Děkuji, Roman. Vážené dámy a pánové, já jsem rád, že můžu být u vás na univerzitě ve Českých Budějovicích. Musím mluvit anglicky, protože myslím, že to bude lépe pro mě a také pro vás. Okay, at the University of Bayreuth, we are developing dynamic geometry software since the year 2097 at the Center for Mobile Learning with Digital Technology. And 20 years ago, I had the possibility to visit your university thanks to Pavel Pech. He invited us to the first conference here at České Budějovice. And there we presented our dynamic geometry software, GeoNext, which was the first Java-based software for doing interactive geometry and interactive calculus as well. These interactive constructions could be implemented into websites, and 20 years later, you are all familiar with this kind of software using in the web. So some years ago, we started to realize another approach, and that's the reason why I'm talking today about to get in touch with geometry and beyond. And I want to present a new project called Sketchometry. And I divided this talk into two parts. First, I want to introduce the software Sketchometry. And after that, I want to present a didactical concept, how to use Sketchometry in the classroom. So what's special about Sketchometry and the use of the finger to construct, to create geometric constructions? We have to go back in time. Not 20 years, not 15 years, not 50 years, but over 2,000 years. And in antiquity, people used their finger to draw and to illustrate ideas and consideration using the finger to draw in the sand. The people had neither paper or pens nor pencil, so the tools were missing to generate exact, accurate figures. And I think you are familiar with the tragic end of Archimedes. He also used the finger to sketch in the sand. And one time in the city of Syracuse, he was at his scholar house doing geometry, and he used his finger to illustrate geometric considerations. And suddenly a soldier went in and destroyed his visualizations, his drawings in the sand. Archimedes was very angry and told the soldier, "Nolli turbare circulus meos," don't disturb my circles. It was not so good to say that to the soldier, because the soldier killed Archimedes. But the idea using the finger is just vivid. And we use this idea for sketchometry. But what's the problem with using the finger and sketching in the sand? It's very imprecise. you can't do exact constructions. It's good for basic considerations. Here, this photo I took on the beach at the North Sea, and it's very difficult. And in those times, geometry took place in the people's mind. And geometry was a kind of abstract science. And nowadays, it is a little bit different. We have exact tools. We can use pencil and ruler. And students at school or at university, they like geometry because it is very vivid. You can use illustrations, and that's more concrete compared to calculus or, for example, algebra. So this is the idea we want to use in our software Sketchometry. And therefore, we created a user interface. And I want to give you some technical aspects to that user interface. And I will start with the first construction. Here you can see the new board from that Sketchometry. And I need a tool, and what's interesting, this tool is my index finger. So I can use it to draw basic objects like circles, triangles, or lines, straight lines. I can intersect objects, and this is the way of constructing with Sketchometry. And the difference is you can now use the finger, and these finger constructions are converted into exact objects, and you can use these accurate figures to make your considerations, for example. But of course, if you're doing geometry, you not only use these basic objects like circles or triangles, you also need more complicated, more elaborated objects. And therefore, we use a second tool, the so-called gestures. And a gesture combines the characteristic properties object contains. I will do an example. I go to a new board. I want to draw the perpendicular of a line. And therefore, I start with a straight line. And then I have to sketch the perpendicular, and I'm doing it that way. I mark or I sketch the position of the perpendicular, and then I mark the line where the perpendicular should be perpendicular to, and the object appears. Another example, for example, let's do a circle. And I want to draw the tangent at that circle, and I will use a gesture as well. I mark the position of the tangent and the information that there's a right angle between the tangent and the radius. And now I have the object for this tangent. So these gestures, they have their own philosophy. They are very close to the object I want to draw. For example, we have seen the tangent, but here you can see the gesture for the angular bisector. There you can mark the position of the two legs, and in the middle, the position of the angular bisector. And when you are doing this gesture, then Sketchometry interprets this gesture and make the exact sketch of this. So to illustrate that, I want to give a very short look behind the scenes, what happens in the background. And here we have 4 steps. The first step, you are sketching the gesture. And after that, this gesture will be compared as a curve with integrated gesture, so there's a comparison. And after this comparison, we use a pattern recognition, which divides each gesture into different parts. For example, when I'm sketching the perpendicular line, we have the part where the perpendicular line exists, and the part where the original straight line is situated. And between these two lines, there's the right angle. So this is part of the pattern recognition. And the last step, sketchometry analyzes if there are underneath such a gesture the right objects. For example, if I want to draw a tangent, there must be a circle, for example. I can't draw a tangent on a triangle, for example. Or other example, I can draw a curve here, and then I can do this using the tangent gesture, and sketchometry interprets there's a curve, I can draw a tangent. And for example, here I can also use a gesture, for example, to draw a slope triangle, and then I can observe the slope of this tangent in that point. So that's the idea behind sketchometry, how these gestures are implemented. And one thing which is even more interesting, I think, is how we can use the finger to foster individual learning. And there are some interesting results. Of course, you are all familiar if you're regarding children or toddlers. They use the finger to count numbers, to add and subtract. They count quantities, and they point to individual objects. This means they want to be sure that they don't miss any objects. And even we as adults, we use our fingers to count. If I'm talking, I say first, second, third, to be sure that I remember everything. So this is a common method we use in learning. But there are also some interesting studies on that subject. And several studies from Australian scientists shows that there is a strong connection between the index finger and the method of tracing figures to solve mathematical problems. I have chosen an example from a textbook here, and in that research of these Australian scientists, they gave students age 9 to 15 geometrical task with some texts and some illustrations. And they had to read and to interpret these illustrations and text. And additionally, they encouraged the students to trace important parts of these illustrations. For example, here the inscribed quadrilateral of this circle. And what was astonishing, Paul Chins, the leader of this research group, mentioned, our findings have a range of implications for teachers and students alike. They show math learning by young students may be enhanced substantially with the simple addition of instructions to finger trace elements of math problems. So they tried to find an explanation, and the explanation was pointing with the finger increases attention. If you point on an illustration, you are focused on this illustration, and this generates a higher processing priority in the brain and reduces the load of working memory you need to interpret these illustrations or text. And you are activating additional brain regions compared to only visual perception. These brain regions are not activated if you are just looking at an exercise. And what was interesting, they made additional studies with adult people, with medicine students, and they gave them, they had to learn the parts of the body in anatomy, and there they were encouraged to trace the parts of the bodies, the bones, the names of the bones, and they had the same results. The students who traced the illustrations with the finger remembered more of the content compared to the other groups. And here, I think this is a very important sentence by Paul Jins. The simple and very important zero-cost teaching approach can enhance the effectiveness of mathematics instructions across multiple areas of the subject. This was the result of the study with the small children. So using the finger is a very important, or tracing with the finger is a very important method to foster learning, but we also have historic examples. You are all familiar with Maria Montessori. She made letters out of sandpaper and asked her students to trace these letters with the finger to learn the shape of the letters. And in that case, they used the index finger. And what was interesting at those times, there was no proof of the efficiency of this method. But Maria Montessori, she relied on her intuition. And later, of course, this was proof that this is an effective method. So using the finger helps students to focus on problems. And that's the reason why we use this learning method with sketchometry. And therefore, sketchometry uses these advantages of linking motoric brain regions in learning and understanding mathematics and learning and understanding mathematical problems. And that's the reason why we created these gestures in that way. They are very close to the object. And here I have the perpendicular line because I sketch part of the perpendicular line and the characteristic property of the right angle. Here, the perpendicular bisector, I mark the position of the bisector and the information. You need 2 points to draw it. And here, the tangent we've seen before. And what's different to traditional dynamic mathematics systems, these fine motor movements of the finger, when you're sketching a gesture, activates these fine motoric brain regions compared to clicking on objects. Imagine in a traditional geometry software, you want to draw a circle. You click on the midpoint and a point on a line. Or sometimes you click on the midpoint, then you drag outside and the circle appears. When you draw a straight line, you click on the first point and on the second point, and then the straight line appears. This also the same action, drag on the first point, drag away, and you have the line. If you want to draw a perpendicular, you point or you click on the line and a point where the perpendicular should go through. And it is always the same action. You'd click 2 times. Here in sketchometry, every gesture is related to a specific object, and we create or we mark, we sketch part of these objects. And that's what's special about this method of using the finger. And what's even interesting, I forgot at that point, using the finger is not only useful for learning mathematics. There was a study at the Max Planck Institute at Leipzig, I think last year or the year before, and they had a study with language learning students, and they asked the students to use gestures by learning vocabulary and words. And the students who acted, a simple example, this is a house. To gesture to make the shape of a house, for example, for them it was easier to remember the content they had to learn. So this is the idea of using the finger in sketchometry. And I want to give you another example. Therefore, I will start with a new board. I put 2 points, A and B, on that board. Then I draw a straight line through these points and a third point which should be reflected through this line. And therefore, I use an additional gesture. This is the gesture for reflection. I start at the point, go to the line back, and the reflected point appears. Of course, it is movable. And now I can draw a quadrilateral. Perhaps what's important at the top, at the left top, you see two buttons. The first button, there you can stop dragging, and the second button you can stop constructing. Sometimes this is necessary if you want to show something, then I deactivate this construct mode, and now I'm activating the construct mode and activate the drag mode and activate the construct mode. Now I'm only able to generate new objects, but I don't need that circle. I want to draw that quadrilateral. Then I activate drag once more. And as you see, this is movable as well. And now, of course, we have a kite. And perhaps I want to do some other construction. I want to draw the midpoint quadrilateral of that kind. And therefore, I use gestures as well. For example, the midpoint of the line AC prime. Therefore, I just use a gesture that looks like a loop. Oops, sorry. I missed point C prime. And then I will have the midpoint. And you see in the blue line, there is written thread. It's the midpoint. And so it is a very easy and intuitive way to do these constructions. And of course, now I can sketch the midpoint quadrilateral. Perhaps sometimes it's useful to change the color as well. Then it is easier to talk about the objects. I can talk now from the green quadrilateral. And of course, you know, this is a rectangle. And this could be a point to start investigations, to make considerations for the student. And that's the next point I want to stress. Here we have the idea using the finger, using the idea of sketching in the sand, and using the finger in sketchometry to do precise constructions. So in the last years, especially the years of the pandemic, a lot of digital tool appears, and we use a lot of digital tools at the classroom. And therefore, it's always important to have a didactical concept to use these tools at school. And the situation, I don't know whether the situation in Czech Republic is the same. A lot of administrative people, they say, here you have some iPads, you have some tablets, we buy you the software, and please work with the software, because digital is good, analog is bad. Okay, this is a little bit strange, this thinking, but it is necessary to have a concept. And today I want to present a concept we developed at our Center for Mobile Learning with Digital Technology, the so-called learning modules. And let's have a look at these learning modules. And we want to want to see these learning modules as a way to integrate digital tools in a traditional way of teaching. This shouldn't be a disruptive way of teaching. So everything, so we stop only using digital tool. We want to foster a combination of digital tools and traditional tools in this way of teaching. And these learning modules, we call them Unterrichtsbausteine in German, are divided into 5 parts. And for these parts, we used a traditional way of using materials, we used worksheets, PDF worksheets, so that it is possible to use these worksheets in a printed version and in a digital version as well. So you don't need a learning platform, a digital learning platform to use them. You can just print them. So let's have a closer look to these to this structure. We have an information sheet for teachers, the core, a student's worksheet, then some result sheets, an exercise sheets, and additional videos to the student's worksheet. And let's now have a closer look to these parts of a learning module. The first part is an information sheet for the teacher. Here we have prerequisites and objectives for the students' worksheets. And it is important for teachers to know what should the students know to use these worksheet or this learning module, and what's the goal of this learning module. In this case, I took the example, explore the midpoint quadrilateral of a kite. I've just created this example. And here they should explain why this midpoint quadrilateral is a rectangle. And the second part of such a information sheet is very important because it tells the teacher who wants to use such a learning module, what do I need for sketchometry? Because if you are using new apps, you have thousands of tools and ideas behind these apps, but often you only need some of these tools, and here these tools are described. You only need 4 tools for this learning module. This is the gesture for the reflection. Then I use the midpoint, and if you want to investigate, you can use the circle gesture and the angle gesture, and you need a possibility to measure lengths and angles. So that's important, what's necessary for sketchometry, and you only have to explain these features to your students. And the third part of such an information sheet are further explanations of and tasks. For example, to task for gifted students, and some ideas how to connect this learning module to the curriculum and additional information. And therefore, we have these informations, prerequisites or objectives, and notes on geometry. So let's go to the core of such a learning module. And this is, of course, the student's worksheet. And these students' worksheets, they always have the same structure. We have the first part, which is the construction part. And here the students always start with a new board. We don't give them prepared constructions, because when you give them a prepared constructions, you are sharing your idea of the problem. In this case, they should do such a construction step by step. And here, the first thing is to create such a kite. In the prerequisites was noted they should know how to do that. And then they have to draw the midpoint, to sketch the midpoint and the midpoint quadrilateral. So now we are ready to do some experiments. And that's the second part of such a learning module in the students' worksheet. They got tasks for exploration and doing experiments. They should drag these objects. They should write down conjectures, and they should try to explain why is the midpoint quadrilateral a rectangle. So here we have these 2 parts, an instruction part for the construction of such a situation, and for the exploration part to give tasks for the students to do some experiments with such an illustration. What's funny, we observed some things using these learning modules at school. If you give students such a worksheet, some students don't read the text. I think you are familiar with this problem, and they just have a look at the illustration and they try to do such an illustration. And we observed the situation that the following things happen. They construct this one, they put points on that, and they are happy because it looks the same as in the worksheet here. But of course, the mathematical relations, they don't exist here. So sometimes the teacher has to ensure that they read the tasks and that this construction is done correctly. Okay, this is the student's worksheet, the core of such a learning module. And then we share some result sheets. This is important because for many students, it is not so easy to make a real good documentation, to write down their thoughts, to write down free texts, to make sketches and considerations. And therefore, we offer a predefined structure for them. For example, here, to write down a conjecture about the midpoint quadrilateral, to make additional sketches on the paper so that we combine the digital way of exploration and the traditional analog way of doing sketches with compass and ruler, for example. And of course, here you also have the possibility to ask for individual notes and sketches. The next step is an exercise sheet. There are tasks to practice. There are tasks to deepen the student's worksheet, the content of the student's worksheets, and further and additional topical suggestions and thematic suggestions. For example, in this learning module, here you can see a picture or a painting of our friend Eugen Joost. He is a Swiss painter. And here, of course, we have a square and we have some inscribed midpoint quadrilaterals. And the students are asked to use these midpoint, to describe this structure with these midpoint quadrilaterals. So such a worksheet can be used, for example, at home to deepen the experiments done in the classroom, or you can of course you can use it at the classroom as well. So this is the exercise sheet. And now the last thing about such a learning module. This is a video, and here you can be very creative. We used videos for introduction, for example. I brought a small example. Here we have a screen recording of sketchometry to introduce how to generate this kite, how to construct, how to sketch this kite, and then how to realize the midpoint quadrilateral using this midpoint gesture. In this case, you see the new version of sketchometry. This is a beta version, which will be released next year. But the way of constructing is the same. So here we have the midpoint quadrilateral. So for students who are not familiar with sketchometry, this is a possible way to introduce them to the software, and they can watch the video, and after that they can generate this construction. Okay, that's a short video, and now you can do experiments. Of course, we can also offer videos for repetition or for giving summary when we record the experimenting phase of such a video. And one very interesting thing about the videos was the idea to let the students create videos with the content. They do their experiments, they use the screen recording function of a tablet or a smartphone, and then they were able to share their work with their classmates or with the teacher. So using such a video offers a variety of possibilities to deepen the access to the student's worksheet. So this is such a learning module, such a Unterrichtsbaustein with the 5 parts, and the core is this so-called student's worksheet. So let's have a look at some of the advantages of these learning modules. And of course, as we do it in dynamic geometry, we can use these learning modules to do experiments in mathematics. Like in physics, you put your things together, then you make your experiment, you change the parameters, and you observe what will happen. And you can do the same with sketchometry as well. And we don't use ready-made results. The students have to do their own constructions in the first phase, in the construction phase. And we use a kind of adaptation of the learning method, think, pair, share. I think you're familiar with this learning method. At first, the students that try to solve a problem by their own, then they share their ideas with other students in the class, and after that, they can share their results and considerations. So we adapted this method in a way that we are dividing into 5 steps. Of course, the first thing is the constructing phase. Here, the students, they work alone, and then they start exploring and documenting. And this is the step where they can work together with the partners. Often in school situations, if you're using tablets, you have the situation that 2 people are working together with a tablet. So even this constructing phase can be done together. And documenting is important to make the students aware of their considerations, to store them on paper, make them to rethink their considerations. And after that, we start the discussing and the presenting in the classroom situation. And this is a way of fostering inquiry-based and independent learning using these learning modules. And we have another advantage. The students, they can use their own devices as well. Tablets and smartphone at school, sometimes, mostly we have smartphones. Every student has its smartphone, and you can be sure they forget ruler and compass. They don't forget the smartphone. And what's important here, they can use the smartphone as a learning tool. Normally, they use their smartphones for getting into contact to each other, to be on social media, to use smartphones for gaming. And here we have the possibility to have a learning device. And during the pandemic, a lot of our cooperating teachers, they used this method to teach because the smartphone often was the only device the student had available at home. Because, for example, there was a computer at home, but they have to share with the parents and their siblings. And the smartphone, this device was available for nearly every student. And so they can use it as a learning tool. And sketchometry is a tool we want to use, let's say, like the calculator. If you want to calculate something, you use the calculators for some minutes, then you will put it away. And sketchometry, you can use it in the same way. You do some constructions with sketchometry, And after that, you can put the smartphone away and you can go on with a traditional way of teaching. And what's also important, students can use their own devices compared to use devices from the school. So this is the idea of learning modules. I have to have some minutes left. This is the idea of the learning modules. And at the moment, we have started another research field. And this is also very interesting. In the description of my talk, I mentioned the word assessment. And the situation in Bavaria is the following. Our schools, they have a so-called Bavarian school cloud. And within this school clouds, there are over 300,000 students from every school in Bavaria. There we use a Moodle system to share content. We have courses for our students. And there is the possibility to include assessments. To make tests for the students, to evaluate these results. And often these tests look like this. This is a very small one. I will read it. Find the area of a triangle with base 6 and height 1.3. They calculate the area and then they can input the answer and go to the next test. Sometimes we have symbolic input, but what's interesting, you can also use geometrical input and you can use geometrical tasks. In that way, change the position of points A, B, and C. So the triangle ABC has an area of 16 square centimeters. Note the specified unit. Here I have the unit 2 centimeters. And now the students can change the position of this triangle. And they submit this. And now you can evaluate the answer whether they found a triangle with the given area. So this is a way of doing, of implementing geometrical input in learning platforms. But our idea goes a little bit further. We want to enable students and teachers to make sketched answers. For example, if you draw the graph of a function, or you present the graph of the function, another answer could be sketch the derivative directly into this construction. And this sketch can be interpreted as a curve. And when you submit this, this can be evaluated, and you can use these interactive assessment tools. So the next step is to find ways how to use these sketching abilities to create assessments. So that's a short, this is a future field of research, but the main thing are our learning modules. And I hope you could get the idea behind our sketchometry project. So we have the software. This is one part, using the finger to sketch individually, to change these sketches into exact figures. And then you have the possibility to change, to alter these constructions, and you can make your considerations, or your students can make their considerations, and they have to write down their conjectures, and they should prove these conjectures. And to integrate this into classroom, we use these learning modules where you start with a blank, with a new board, and then the students can develop their ideas in a guided form. They get the instruction in the construction phase of the student's worksheet, and after that they should do experiments with this construction, with these constructions, and they will document these ideas on their worksheet. So this is an approach of inquiry-based learning with sketchometry. And at the end, I want to say, Děkuji vám za pozornost. And I think we have some minutes left, yes? You have the possibility to try it out. And this afternoon, I will give a workshop where you can get in touch with geometry, with sketchometry, or you can get in touch with sketchometry. The actual version I showed you here, there we have a Czech version. At the moment, we have a public beta version. This beta version is in a very early state. This means we change a lot of things there every week. So you can use it. I used it in the video, for example, and we will offer this version next year, in the beginning of next year. At the moment, we have an English and a German version. So if someone is interested in translating sketchometry, don't hesitate to ask. It would be a pleasure to be part of the project to make a Czech version of this sketchometry, this new sketchometry version. So thank you very much. I hope you will enjoy sketchometry, and jestli máte otázky, se ptejte. Děkuji vám.
Thank you very much for your interesting and inspiring lecture. And to jsem říct já, jaké máte.
Děkuji vám za pozvání. Yeah.
That's actually not a question, but you know, your speech was breathtaking. It was really awesome, and I can't wait to try sketchometry.
Thank you.
And question is it free?
Yes, of course, yeah. We develop sketchometry at the university, and this is really an advantage. We have at Bayreuth, we have several schools which are cooperating with the university. These schools are not only in Bayreuth, but in the northern part of Bavaria. And there are several teachers who are working with us together at the Center for Mobile Learning with Digital Technology. And we have regular meetings. And for us, this is very useful because our programming team invents new features for sketchometry. But a technical invention mustn't be good at school. So they are able to test at school. And before we are offering these features in a new version, they will be tested. And as we are from the university, we don't have the necessity to get money for that. And so we are very lucky. Sometimes it lasts a little bit longer because we are not only developing sketchometry, we have our lectures as well. And as David said, our hobbies. So we were in a lucky position. Sketchometry is for free, and it will be free in the future as well. At the moment, it is not open source software. That's the reason, because our developers, they want to make the code nicer to get out. So if the code is refreshed, then it will be open source. At the moment, they are not so happy doing that at that time, but the software is for free. And we also have materials. Perhaps, Roman, you sent me some email. I hope I will find it here. Perhaps you can say. No, this is, no, that's not the right thing. Here. There was a student at your university, yes, and she wrote a bachelor thesis.
Bachelor and diploma thesis. She wrote on sketchometry. We checked, it's available at our website, and I think that can recommend it.
Mm-hmm. And for example, here you will find a gesture overview, how to, for example, here, Krušnice and Primka, how to use these objects. And of course, on our website, we have these materials as well, but not in Czech. But there is a Czech version. And I think it's always important for the students at school to have materials in their mother language. And of course, English materials are available. And for some students, it's better to have it in the mother language. So here are the materials. Yeah.
I have a question. I checked this tool. It's absolutely great. I'm excited. Especially that I can enter the formulas for functions. Combine it with
yeah.
Yeah, the problem is that it's evidently for mobile phones. So I expect, for instance, I want to edit the parameters of the function that I can use right click, or I can hold shift to select.
Is there
a mode to switch it to work it as expected?
So you need a browser to do sketchometry, and for example, in that case, I think here I have the better version. This is the browser. Here I use sketchometry inside the browser. So this is possible, yeah. But there's one difference. If you are sketching lines, here on the tablet, I can use 2 fingers to change the position. Yeah, this is the problem. And this is the only problem you have. In this way, you have to use 2 points to change this position. Or if you want to draw a circle and you want to change the radius, you can use 2 fingers. It's not possible on this device, so you have to use the keyboard. So it's not 100% available due to the abilities you have with the mouse. You don't have 2 mouse cursors, you only have 1. So this is a difference. And sketchometry on tablets, there you have full access using 2 fingers or even more fingers.
The question could be, would you plan to have it for a computer?
At the moment, there are no plans to do that, because the main purpose is to use sketchometry with touch devices. At our schools and some schools and universities, they also use these interactive whiteboards, and there you have the advantage. If you draw on such a whiteboard, the students see immediately how a gesture works. Here, in this case, I can do it as well in that way, but they don't see where my finger is. We used to display this cross here that they can see when I'm using a projector, where's my finger touching the screen. But using a smartboard, there's the advantage that you can see how the tangent how the gesture for the tangent works. Some of them, they up to 10 fingers. It depends of the model, of course. Yes. Or you just try sketchometry. No.
So I have a question. Is there any connection between artificial intelligence and
the gesture recognition? There we use kind of neural learning. But at the moment, there are no plans. Yesterday, we talked about using the voice to control dynamic geometry. This could be interesting, but I think in a classroom situation, using the voice perhaps isn't such a good idea, but if at home, of course, this could be a way to integrate a new user interface.
I wrote, for example, the control.
The underlying, you can use the underlying library. It's called JSXGraph. There we made a lot of interesting approaches to use ChatGPT to write down, create a web page using JSXGraph and display a square with a red diagonal, an interactive square, and then it generates the whole web page. And what's even interesting for teaching, it explains how this web page works and what's interesting and what's important for the parts. At Sketchometry, we have to be a little bit careful because this, if you're developing software for schools, it has to work and experimenting is a little bit different. So this is a way for using JSXGraph, the underlying library, not for the sketchometry at the moment.
It's like that artificial intelligence does not have fingers.
Mm-hmm. Yeah.
I'm just curious, where have you seen this?
Mm-hmm. Concerning geometry, the lower secondary education, when you are doing reflection, for example, and when you are examining quadrilaterals in this way. And we have some features for calculus as well. And in the next year, we want to enlarge this way of sketching add this way of sketching for calculus as well. So, for example, then you will have the possibilities to use sketching and gestures for derivatives and integrals. So for the upper secondary education, but at the moment, this the main students are working in lower secondary education. We had some experiments with primary schools. For them, it's also interesting, but it's not the main group we want to attend. You had another question?
Okay. You have already shown us some simple constructions.
Mm-hmm, mm-hmm.
Do you have some really hardcore constructions to show us?
As we are beginning from, it is possible. I don't have the constructions prepared. I can show you the reason why it is so. I reset this version to make it the Czech version, and I don't think you will use sketchometry for very hard and complicated construction, because the way of interacting, starting at the beginning, is a different approach. It's for basic considerations. Yes.
So for the visualization.
Yes.
But I think for the construction of triangles, where I have to do 10 steps, it's quite complicated.
Perhaps we can do some constructions. You see, it is a very quick way of doing that, adding some perpendicular lines. I will make this construction. For example, I want to draw the circumcircle, and what else? For example, the perpendicular bisectors, they meet in, no, this was,
I trust you,
it's possible. Perhaps you have to test a little bit. So join the workshop, and after the workshop, you're able to do that. Děkuji vám. Děkuji moc krát. Děkuji vám za pozvání.